Hey everyone, welcome back to another video of mine where today we're going to be solving Leetcode problem 1 titled TwoSum, right? This is a very legendary problem on Leetcode on the website, and it's typically where everyone's programming practice for technical interviews really starts, and that's where the journey really begins of technical coding interview practices, right? So I think it's a very, very essential, vital problem to go over on my channel, as this also is a very popular FANG coding interview question, and there is definitely a good chance that you may get it, especially if you're applying to a relatively lower position, right, including an internship or anything around that level, right? So we're given an array of integers nums and an integer target, right? And we simply need to return the indices of the two numbers such that they add up to the target, okay? So we may assume that each input would have exactly one solution, and we cannot use the same element, or basically the same element from the same indice within our nums input array twice, right? Or basically more than once. And this is actually a very helpful line of criteria because this basically eliminates any weird base cases or edge cases that we have to look for within our problem statement, and this really makes it a lot more straightforward, right? And we can simply return this answer in any order, basically meaning that we can return the indices of the two values that sum up to the target in any order. It doesn't necessarily need to be sorted, and of course in this problem it doesn't really matter. So in example 1, we have a nums input array of 2, 7, 11, and 15, with our target parameter being equal to the integer value of 9. And so we output a list of indices that actually that are actually within the range of the length of the nums input array that actually have elements of that indices that sum up to the target, right? And the reason why we output indices of 0 and 1 is because nums at 0 plus nums at 1 is going to be equal to 9, which in this case is basically equal to 2 plus 7, right? And that of course equals to 9. And so we'd simply return the indices of those two values within our input array nums, which is basically going to be 0, 1 in this case, right? And applying that same logic to examples 2 and 3, we respectively output the lists of indices 1, 2, and 0, 1, right? And of course, we don't really have any base cases, as I talked about before, as every single input is going to have exactly one valid solution, right? Which makes this really, really easier and simple. So you may be thinking, how would the average person just brute force the solution, right? And that would basically be going through every single pair within the input array nums and checking if the elements at those specific indices, or basically nums at I and nums at j, actually sums up to the target. If it does, we can simply return a list of those two indices, and of course the iterators that you use doesn't have to be I and j for the nested loops, but rather any iterator name that you'd like, unless it's like for nums or any parameters or keywords that are in the Python programming language, right? But that is actually a very slow algorithm, at least for this problem, right? As that would be big O of n squared, where n is simply the length of the input, which in this case is going to be the length of the input array nums, right? And why is big O of n squared very slow? For this problem, we can actually optimize the algorithm to be O of n, right? And you may be thinking, how do we even do that, right? How is that even possible? Right, and that is basically using a hash map solution. But before I get into that, I'd like to show you the brute force solution using nested loops, right? So we would say for I in the range of the length of the numbers, right? And we'd say for j in the range of I plus 1 till the length of the numbers, just to make sure that we explore every single unique pair of elements within our input array nums and avoid any duplicates, hence the element after the ith index here, I plus 1 length of nums. We check using a conditional if nums at index I plus nums at index j actually equals to our target. Great, we found a pair of elements that actually sum up to the target that are within our input array nums, and we can simply return a list of those two indices. But this is, of course, very slow, and this is going to require us parsing or processing through the input twice, or basically O of n squared. We can do a lot better, and like I was saying before, we can sort every single element that is contained within the input array with its corresponding indice, and then we'll loop through the array just once for it to be a linear time solution, or basically O of n, and we'll have a missing variable basically initialized to be the target minus the current number that we're looking at in this specific iteration, using the enumerate keyword in our nums input array to store every single element in the input with its corresponding indice, right? And if our missing number, or basically the second element or value in our pair that actually sums up to the target, if that's actually in our hash map that contains all the elements of the of the input array nums, we can simply return the indices of those two values that sum up to the target within a list. Otherwise, we can update our hash map to be storing each element with its corresponding indice. And we'll do this like so. We'll literally create or initialize an empty hash map using the hash map variable name, right? And of course, this isn't actually a keyword in Python. And this is going to be denoted as an empty hash map, as signified by these adjacent curly brackets, right? And if you guys aren't aware, curly brackets in Python simply signify hash maps, okay? And then we'll actually enumerate through the input array nums that actually just store every single value with its corresponding indice to actually ultimately return that indice once we actually find this missing value and once we actually get a valid pair that sums up to the target. So we'll say for I and in enumerate of nums, right? We'll say our missing number, basically the second element in our pair, is going to be equal to the target minus n, right? This is basically how that's defined. And to kind of visually depict this, and let's just say example 1, let's say our n in this specific iteration of our input array is going to be 2, right? In this case, our target is 9, and so the missing value, or basically the second value pair that we're looking at in our nums input array, is target minus n, right? Which in this case is going to be target, or 9 minus 2, right? Basically the nth value in this case is going to be 2 for this specific iteration, right? Is 9 minus 2 or is basically 7 in my input array nums? Yes, it is. It is actually the next indice right after 2, right? If it is, then actually I can actually have a conditional to check that and simply output those two indices within a list. So I'll say if missing is in the hash map that contains every single element with its corresponding indice of our input array nums, I can literally just simply return a list of a hash map. Okay, this should actually be hash map, sorry. Okay, anyways. If missing value or element is actually within our hash map, then I can simply return a list of hash map at that missing value and basically just I, right? And to kind of just go over what this does is, basically on line 6, I check if the missing value or the second element in our pair that's supposed to sum up to the num, if it's actually in the hash map, great, we've found a valid pair, and we can simply return the indices of that pair, right? We can simply return a list of hash map at that missing, right? Because hash map at the missing is going to store hash map at that missing's index, as denoted by this enumerating function, right? And that's going to be the index of the missing element, right? Basically the second element, and I is going to be the index of the nth element, or basically index at I, right? As denoted by, or basically nums at I, as denoted by this enumerating function, right? Because it literally stores n with this corresponding index I, right? That's exactly what the enumerate function does, right? Of course, if we don't actually have a missing variable or our second value pair in our hash map, we haven't found a valid solution, or the valid number that we're looking at isn't actually stored in our hash map yet. So we'll have an else condition on, say, h, or basically hash map at n is going to be equal to I. So basically hash map at that value n within our input array nums is going to be equal to the I, or basically the index that it's stored at within our input array nums. And so unless I made any errors here, this should loop through and iterate every single element and basically check if it has a missing or complement number that actually sums up to the target with it. And if it does, we can simply output the list of those two indices. Otherwise, we can update our hash map to store the nth element with its corresponding indice and keep doing that, or keep updating our hash map until we actually find a valid solution, or a pair of numbers with its corresponding indices that are actually within the input array nums that actually sum up to our target. And as you can see, this is just about as efficient you can get, beating 87.15% of users. Runtime complexity-wise, taking only 53 milliseconds, and memory-wise, it only takes 17.74 megabytes, beating just over 30% of users, right? And this is going to be a linear time solution, as we literally just only loop through the array once and store every single other corresponding value or missing number in the hash map, so we can just check if it's actually a valid solution that's actually contained in the nums input array, and simply output those two indices that actually sum up to the target, right? Otherwise, we can simply update our hash map with that corresponding indice of that nth value within our hash map, and we can keep doing that repeatedly for this loop until we actually find those two valid pairs that actually sum up to the target. And the great part is, we don't even have to have a base case of if we never find a solution, because we're guaranteed that we're going to have exactly one solution for any single input in this problem, right? That's what makes this problem so nice and straightforward, right? With such an elegant solution. So if you guys enjoyed this video and learned something new, please consider liking this video and subscribing to my channel. It really, really does mean a lot and motivates me to keep going. And without further ado, I will see you guys in the next video. Bye-bye.